Here we have a problem that states a freight train has a mass of 1.5 times 10 to the 7 kilograms. If the locomotive can exert a constant pull of 7.5 times 10 to the 5 newtons, how long does it take to increase the speed of the train from rest to 80 kilometers per hour? Now, if you want to work this out on your own, I laid out the steps to solving this problem, and you're going to want to convert kilometers per hour to meters per second, and then you're going to want to find the acceleration given the force and mass, and then use that acceleration and the other given variables to find the time. Now, some important equations that you're going to be using are F equals ma, and the final velocity is equal to the initial velocity plus the acceleration times time. So, first we are going to convert kilometers per hour to meters per second. So, we have 80 kilometers per hour, which we want to convert to meters per second. So we're going to do some dimensional analysis to do 80 kilometers per hour times 1,000 meters and 1 kilometer times 1 hour divided by 60 minutes times 1 minute divided by 60 seconds. So, by doing so, our kilometers will cancel, our minutes will cancel, and our hours will cancel. And we will be left with meters per second. So, we're going to do 80 times 1,000 divided by 60 divided by 60. So we have a final velocity of 22.2 meters per second. Then we want to find the acceleration given force and mass. So we are using the equation F equals ma. So we have a force, the pulling force of 7.5 times 10 to the 5 newtons equals the mass, which is 1.5 times 10 to the 7 kilograms times the acceleration. So we are going to have an acceleration of 7.5 times 10 to the 5 divided by 1.5 times 10 to the 7. We're going to get an acceleration of 0.05 meters per second squared. So, we are going to make a little table of the variables we have, which is the acceleration, the time, the VF, and the initial velocity. So we have our acceleration now of 0.05 meters per second squared. And we want to find the time. We have our desired final velocity of 22.2 meters per second, and our initial velocity of 0 because it starts from rest. So we're going to be using the equation Bf is equal to Vi plus the acceleration times the time. So we will have our final velocity of 22.2 meters per second equal to our initial velocity, which is 0, plus our acceleration of 0.05 meters per second squared times our time. So our time will equal 22.2 divided by 0.05, which equals 444 seconds.